So about 10-ish years ago, I was hired to Netflix. I had the equivalent of like an availability czar role. And one of the things that fell under my purview was a charter for a chaos engineering team. At the time, chaos engineering was a buzzword in a series of blog posts from years earlier at Netflix. Not a lot was being done with that outside of a program called Chaos Monkey that was running. And so it was up to us to figure out what chaos engineering was and how to build a team around it and establish our own success criteria and all of that. So I went around the company and then around some other industries in Silicon Valley and asked, so what's chaos engineering? And the answer I usually got was, oh, that's when we break stuff in production.
Yeah.
And as cool as that sounds, that's a horrible thing to do in practice for no purpose. So instead, we sat down, metaphorically locked ourselves in a room for a month and looked at resilience engineering in particular, borrowed a lot from existing research into critical systems and high availability and reliability in systems outside of software, like nuclear power plants, air traffic control, shipping, railroads, things like that, military operations, and found that there was a ton of research outside of software that just hadn't been recognized or brought into software. So we borrowed heavily from that material from Sidney Dekker in particular. Lauren Hochstein was on the team, so he had a lot of input into the development of the definition of chaos engineering, which we put up at principlesofchaos.org. The definition's still up there, translated into a dozen or so languages now. Yeah, and so that became chaos engineering. Then I went on to build and manage that team at Netflix for 3 years. We built some of the most sophisticated chaos engineering tooling that's out there right now. We started evangelizing it across the industry. Gartner tells me that 80% of the major banks in the US now have dedicated chaos engineering teams, which is good. So adoption is still increasing. So if you think about all of the fields in incident management or around reliability, they're all about waiting for something bad to happen, an incident, and then how do we deal with that, or how do we analyze it, or how do we prevent that particular thing from happening again? All of which has to, by definition, take place after the incident. So none of the current best practices or software norms are proactive. And I would say this is true for testing as well. Again, I'm not saying to not do any of these things, but testing relies on an engineer to think of the things that they could imagine going wrong and then codifying a check based on something that they know about the system, which means they have to know it about the system. Chaos engineering is part of a shift to an empirical practice and an experimentation practice, what basically the success of the healthcare system in Western culture is based on, to discover things that you didn't know about a complex system and then use that to adjust behavior over a longer time frame. And those small shifts and small learnings lead organizations that embrace that to a very different place than the intuitive quick fixes that, again, most of the industry still resorts to.
If people want to get started with chaos engineering, if you talk to engineers, they're quite okay to know what they're getting out of it. But I mean, then there are also people, they are on higher levels and they don't really know what I'm getting out of it. So why should I break something? What is like the outcome?
Yeah. So I would say, first of all, you're not necessarily breaking something, right? It's chaos engineering is a lot more than just failure injection. Failure injection could be part of it. It doesn't have to be. And all of that is part of a broader thing called continuous verification. That's the broader umbrella for reliability efforts like this, or a gold standard for reliability efforts. When we started evangelizing this, we started running conferences. The tech companies were engineer-led, so they were quick to jump on board. In the first conference that we ran, had a lot of people from FANG and LinkedIn and big companies in Silicon Valley. They kind of got it, but there were some banks there, some people from banks represented, and they would say things like, "Oh, well, you're talking about advertising and media, and these experiments sound dangerous, and if you go down, it's no big deal, but we have money on the line." Like we can't do the same sort of experimentation that you're talking about. And so we would ask them, okay, so you don't have outages anymore? And they say, well, no, of course we still have outages. Okay, well, if you still have outages, are you just going to keep doing the same thing and expecting a different result? Because we found a different way to work this system. And instead of running into that brick wall, maybe we can help you run around it or get a light to see that, the wall before you smack into it. And turns out that was a convincing argument. A lot of the banks jumped on it. The following year, we had a similar argument from healthcare companies where they would say, hey, media, advertisement, money, that's one thing, but like we can't experiment with our systems because lives are on the line, human lives. Again, same argument. Do you still have outages? Yeah. Okay. Well, in this case, there was a stronger connection because we could say, look, we built this practice on empirical principles of Western science, the quintessential example of which is the double-blind clinical study. Healthcare companies already do chaos experimentation. They just call it something else. Yeah. They do it with lives on the line in medical trials. That's part of their process. In fact, that's a requirement for broad approval of a drug through the FDA here in the United States. So this practice of empirical experimentation, it already saturates our culture. It's all around us. It's really just kind of like a semantic shift to see how that could be applied in one situation versus another. And again, this might be something that feels intuitive, that isn't actually real. I occasionally will run into people who push back on the term chaos engineering because they're like, oh, well, I understand how chaos engineering is important. And it's not that we're engineering chaos, it's engineering around the chaos. But I could never sell it internally because there's no way my boss will go for something called chaos engineering. I've heard that a lot, and I've asked to be put in touch with those people, and I don't think they actually exist. I have yet to meet somebody who said, I won't do that because it's called chaos engineering. I've heard a lot of people who are anxious that they think it will be blocked because somebody won't do something, but I've never actually met the person who says, no, that word scares me. I'm not doing it because I'm afraid of the name.
I can share you a story, but not the name, of a company who told me, okay, yeah, we know it's important. We want to do it, but we already aligned internally and there are some decision levels. We shouldn't call it chaos. We need to find another word, but we want to do it. And it really depends on who you are talking to. And people are still, as you told, afraid of the word of chaos or that you will produce a lot of chaos, but it's the opposite. You're right.
Yeah. And again, I've gotten that pushback and, from my point of view, I don't care what you call it. If the goal is to improve your availability.
Stay on the principles, but yeah.
But I still haven't met that person.
Okay.
I still think it's a group concept of oh, it makes me nervous because it's going to make somebody else nervous.
Yeah. I agree.
I don't think there's an actual person who can't have it explained to them in 3 seconds. No, actually, it's your system's already chaotic, right? Yes. Yeah. Okay. We're going to engineer around that. Oh, okay.